Hey guys, this is Coach Hoffman here, and this is the third day of our Pre-AP Geometry Prep Notes. And we are starting on page 7 down here. This is similar to what we learned yesterday, or last time, about simplifying radicals, but now we are adding some variables. Okay? So I'm going to talk about the two ways to simplify these, and first we're just going to completely split these and look at these separately. So this is actually the same thing as this. Okay, so we're just going to split these, simplify them separately, and then combine them at the end. And I think that's a lot easier way to look at it. There's a couple different ways that we talked about simplifying these. Either you can know your perfect squares, which 2 times 2 is 4, 3 times 3 is 9, 4 times 4, 5 times 5, 6 times 6 is 36, then 7 times 7, so on and so forth. You get the idea. You can know your perfect squares and find one of these, the largest one that goes into that number, or you can just simply factor it out and use the factor tree to simplify the radical. So there's a couple different ways. So one way you can do it, for this one, I'm going to just take the largest perfect square that goes into that. So yeah, 9 goes into 72, but so does 36, and 36 is larger than 9. 36 goes in twice. So you would split these to 36 and 2, because 36 times 2 is 72. And always put your perfect square first. So what happens is it simplifies to 6 square root 2, because the square root of 36 is 6. Okay, so awesome, we've done that side, and this side is done. We need to simplify this side, and then we can combine them. Okay, so anytime you have an even number and you're taking the square root of that even number, you will divide that by 2. So if you've got 4, you take the square root of it, 4 is in the exponent, you divide it by 2, you get b squared. So the square root disappears, and then the 4 becomes a 2. If it was 6, it would be 3. All right. If this exponent was an 8, it would be 4. All right. All you're doing is dividing by 2. You're not actually taking the square root of this number. You're just cutting it in half. Okay. So these are our two answers. We just need to combine those. All right. So notice this is no longer under the square root. It's outside the square root. So our 6 is outside the square root. Our b is outside the square root, and our 2 is under the square root. So make sure you see where all of these numbers are coming from. Our 6 and our root 2, and then our b squared. Okay? And things that are under the square root remain under the square root, like this 2. Those that are no longer under the square root goes in front of it. Okay? You don't put anything behind the square root. Right? So that's one way to solve. Another way to solve would be to use the factor tree. So I'm going to go ahead and split these again. I'm going to write it over here, 320. And then I'm also going to have the square root of n cubed. And we're going to look at these separately. So if I'm just making a factor tree out of this, I'm going to take 320 and divide it by 2. So I get 160, so 2 and 160. And then I'm going to continue. So 160 divided by 2 again is, oh, I'm actually going to put this 2 over here. So 2 and 80. 80 divided by 2 is 40. And then, obviously, 40 divided by 2 is 20. And 2 and 10, 2 and 5. Okay? So what you're going to do is take any number that is a pair, and then those get out of the square root. Okay, so we've got a pair of 2's, pair of 2's, pair of 2's. Those are out of the square root. The 5 has no pair, okay? So the 5 stays under the square root. And these 2's are all outside the square root, but only one of them, okay? So what happens, and one way you can kind of think about it, is all of these numbers are in jail under the square root, and they can only get out of jail if they have a partner, and one of the partners sacrifices themselves for the other one. So, and they have to be the same number to be partners, okay? So these 2 are partners, only one of them gets out. So 1, 2 gets out, okay? And then same thing for this. 1, 2 gets out. Same thing for this one. 1, 2 gets out. Okay, so because there's 3 sets of partners, we have 3 2's outside, and then you just multiply all of them together. Alright, so 2 times 2 times 2 is 8 root 5. Okay, so that is one way to do it. I'm going to show you another way real quick. I've got 320. I want to take all of my perfect squares. I'm going to start from the top and go down. So, you know, you can go up to 121, you can go up to 144. And all these are 2 squared, 3 squared, 4 squared, you know, up through 12 squared. So I'm going to take my 320 and I'm going to start dividing it by these numbers and seeing if any of them come out perfectly. Okay, so 320 divided by 121. Nope, that doesn't work. 320 divided by 100. Obviously that won't work. 320 divided by 81. And I'm just going down the line. 320 divided by 64. Oh, hey, that works. Okay, so once you get to one of these, and the reason I'm not going from the bottom up is because we want the largest number that is divisible. So, this is just another way to get to 8 root 5. Okay, so if this method is confusing for you, you can do this calculator method. So you take that 320 and you realize that 64 goes into it 5 times. So square root of 64 and square root of 5. Okay, because that divides evenly, and if we want to go back, we just 5 times 64, and that equals 320. And then the perfect square, so the square root of 64 is 8. Okay, so if you take the square root of that, you get 8 root 5. And that's the same as that. So those are the 2 different ways. Obviously, you don't have to do it both ways, but just pick a way. You can either do it by factoring, or you can use your calculator to find the largest perfect square and simplify. And then we have this. We have n to the 3rd power. So the difference between this is, remember I told you to divide by 2. You cannot evenly divide this by 2. And you can't have n into a decimal. You can't have n to 1.5, which would be half of 3. So what you have to do is take this and take 1 away. Take one of these n's away. So meaning like this. If I've got n squared, and then I'm going to pull out 1 n, so the square root of n, which these 2 are actually the exact same thing. Okay? So when you multiply them together, they go back to n cubed. Alright, but if I pull 1 n out, now we can cut this in half. Alright, when we cut that in half, it comes out of the square root, because this square root and an n squared, they actually cancel each other out. So those get canceled out, and it becomes just n. Can't do anything with the square root of 1n. Alright? We just have to leave it there. So now we look and we've got an 8 outside of the square root and a 5 inside the square root. We've got an n outside of the square root. We have an n under the square root. Alright? So we need to combine these 2, make it 8n outside the square root. So that comes from there. This comes from here. And then we have a 5 under the square root right here. And we have an n under the square root. So this is where all of these are coming from. And this square root 5 comes from there. Okay, I know this is complicated. This is a lot. One thing I would suggest for you to do right now is to go ahead and try this another time, but without all of this work. So try to see if you can do this by yourself and figure out if this method is easier for you or this method is easier for you, okay? You may also want to rewatch that if you're confused. For this one, factor out the common factor of each expression. So that's different than factoring it completely. This one says completely. This says just factor out the common factor. So you've got to find one thing that they all have in common. And if you're looking, so they don't all have a variable. So n is not something they have in common. What they do have is a similar number. You can notice they're all even numbers. So again, they have a 2 in common. They also have a larger number than 2 in common, okay? They are all factors of 6, okay? So you can pull 6 out and just divide all those numbers by 6. So 18 divided by 6 is 3. 3 in the 4th power. 6 divided by 6 is 1, so it's just going to be n cubed. And then 42 divided by 6 is 7. And that's what you end up with. And that's all you're doing by factoring the common factor rate of each expression. Don't turn this into something more than it is. That's it. Okay, and then for this one, the highest you can go is 2. Yeah, both of these have an 8. Both of these have n's, but not all 3 of them. So 2 is the largest common factor between all 3. So 2 is what you're going to take out. 8 divided by 2 is 4. 2 divided by 2 is 1. And 8 divided by 2 is 4. And that's all you're doing for this. All right, we have what we need, and we can move on. I'm going to show you a couple different ways to factor. As far as anytime this number, so I'm going to call these coefficients, so we're going to look at it like this. X is your variable, plus B, X, plus C. So anytime I say A, B, or C, A is the coefficient in front of the variable squared. All right, the X squared, the P squared, R squared, whatever you have. B is the coefficient in front of just the variable that's not squared. And then C is this number right here that's by itself. It doesn't have a variable with it. All right. So right here, we have nothing in front of P. It's a 1. So P squared is all it is, meaning no coefficient, nothing greater than 1. Like these two have a number greater than 1. We're going to approach them a little differently. For this one, all you need is you need 2 numbers that multiply to equal this. So multiply to equal -3, and 2 numbers that add to equal +2. Okay, so we can find that. So what we're going to do is we have -3. We need 2 numbers that multiply to equal -3. Since it's a prime number, there's really only, all you can do is take 3 and then 1 and multiply them. But you just have to figure out which 2 numbers multiply to equal -3 and add to equal a +2. So basically, where are we going to put this negative to make it a +2? The negative has to go on the 1. Because if you put it on the 3, make this a -3, and then you add -3 plus 1, then you're going to end up with a negative number there. You don't want that. So the 1 is what's going to be negative, because when we add these together, 3 plus -1, it equals 2. So that's what we want. We want to multiply them, 3 times -1 to equal -3, add them to equal +2. We have our 2 numbers. Awesome. So how we're going to show this is P and then +3 because it's a +3, and then P minus 1 because it's a -1, and now it's completely factored. All right, and that's all it has to look like. Another way you can do this is box method. Okay. So the way you do this is you take the first coefficient and variable, so r squared, and you put it in the top left-hand corner box, and then you take this coefficient, 6, put it in the bottom right-hand corner, And then you're going to take these two numbers, these two boxes, and fill it with the numbers that went here. So same thing we just did, but we're using a box. So we need numbers that multiply to equal 6 and add to equal 7. So same idea. So 6 and 1 would be those. The other variable, or the other numbers, 3 and 2 also multiply to equal 6, but there's no way to add them together to equal 7. So that's why we're not going to use these. That's why we have to use 6 and 1. Okay, so we've got a positive 6, a positive 1, and we're going to put those right there. And next to these, we're going to put our variable, because these are the two numbers that add up to equal that 7r, so that's why we're putting r's by them. All right. Now, we take this and we want the greatest common factor of each column, meaning what do these have in common, just like we did up here. They both have r's in common, and that's it. So all we're going to write is r, because there's a 1 there and a 6, so 1r is all they have in common. This right here, what do they have in common? A 1. So this one doesn't have an r, so you can't put an r up here. 1 is the only number they have in common, because 1 times 6 is 6, and then 1 times 1 is 1. Same thing here, r is the greatest common factor. And then here, this is a little different. So there is no r in this box, so you can't put an r out here, but they do have a 6 in common. So you can use r plus 6 and r plus 1. So it's the same idea as what we did over here on number 5. Honestly, you can do either one. They're both correct. They're just different ways to approach it. They're very similar. But just decide, do you like the box method better, or do you like to just find numbers that multiply and numbers that add and fill them in? Okay, it's up to you, however you want to approach it. This one is a little bit different. And so you look and you're like, okay, well, this has a coefficient in front, so I'm going to have to do this differently. But the first thing you want to look at before you try to do box method or do anything crazy are there any common factors that we could factor out, just like we did in number 3 and number 4? And yeah, there are. 2 can be factored out of all 3 of those numbers. They're all even numbers, so we can factor out a 2. Okay, so let's do that. So now we've got b squared plus 15b plus 50. So this is quite a bit different, right? If 2 is factored out, now we can just approach it like we did 5 or 6. So we just need 2 numbers that multiply to equal 50, but also add to equal 25. Or, sorry, not 25, to equal 15. So we want to multiply to equal 50, add to 15. So let's just write the factors out. So 1 times 50 is 50. 2 times 25, it doesn't simplify evenly into 3. 50 divided by 4 also doesn't come out even. 5 times 10 is 50. Ooh, what do we have going on here? These two numbers add to equal 15. So these are those factors we need, because they multiply to equal that, add to equal the second coefficient, or the b coefficient. So great. Now we have what we need. X plus 5 and x plus 10. And that is what it should look like. And that just makes things a lot easier when you go ahead and pull out any numbers that you can before you start to factor. Okay, number 8, a little bit different. With number 8, you cannot take out a 2. Like 7 is an odd number, so you cannot simplify this any further. So we're going to have to look at this a little bit different. And we've got some big numbers, and that's okay. But what you need to do, anytime there's a number greater than 1 in front of the n squared, the x squared, so your a coefficient, anytime it's greater than 1, you have to approach it a little different. You've got to take your a and your c, you've got to multiply them. All right, so we're going to do 60 times 7. We're going to get 420. So 420 is the number that we need to find factors for that add up to negative 76. All right. And I'm also going to set up my box for this. I highly recommend using a box method. So I'm going to put 7n squared there. I'm going to put 60 there. Notice I'm not putting 420. So here, these are the same numbers in those corners, but it actually matches up with this one as well. Here, these two match up. 420 does not go in that box. All right. We need factors of 420 that multiply to equal this, add to equal negative 70. Okay, so I added all of these in. Just going to take 420, divide it by 2, and you get 210. So these are factors of 420. And we're trying to find two of these numbers that add to equal negative 76. So 210 and 2, 420 divided by 3 is 140. Divided by 4 is 105. So these are just factors of 420. Divided by 5 is 84. So 84 times 5 is 420. 70 times 6 is 420. Oh, ding, ding, ding. We've got it. These two numbers can combine to equal that, but we have to do something. We have to take this and make them negative. Okay? So, if we make them negative, negative 70 times negative 6 equals 420. So we're going to call this negative 70n and negative 6n. All right. And then, awesome, we've got our two factors that add to equal negative 76. They multiply to equal a positive 420. Now we can find our greatest common factors. All right, our greatest common factors here is going to be 7n, because there's an n in both of them, and then 7 goes into 70 evenly. All right, 7n, and then for this one, it's going to be a negative 6 is going to be the greatest common factor. All right, so anytime this value is negative, the one with the n by it, this number is going to be a negative. So if this was a positive 6, this would be a positive 6 up here. And that's how I know to put a negative there. All right, greatest common factor for this one, it would just be an n all by itself, because those numbers don't go together, and then there's one n in here, two n's there. But here, it's actually going to be 10 for the greatest common factor, and it's going to be a negative 10 because the 70 is a negative. So 7n minus 6 and n minus 10 are our factors. Okay? Awesome. All right, almost done. So we're solving by elimination here. So we want to find a way to make one of these equal with an opposite sign so that when we add our equations together, we can cancel one of them out. What I mean is I want to either make both of these the same number, the 10x and the negative 4x, or I want to make both of these the same number but with opposite signs. And I think the easiest way to do that is just to make this a negative 8x so that when we combine these will cancel out. And that's what it means by elimination. So the way I'm going to do that is I'm going to take this and I'm going to multiply this whole equation by 2. Okay, and I'm going to rewrite it over here. So 2 times 10 is 20, 20x minus 8y equals negative 32. You have to multiply every single one of them by 2, and then I'm just going to rewrite this one, negative 4x plus 8y equals 0. And then we're just going to add these two together. The reason this works, and you can cancel out when adding them, is because they have opposite signs. So you've got to make sure you do that. If this was a positive 4, you'd have to multiply the whole equation by a negative 2, and it would change all of the signs. But since it was already a negative, we just had to multiply it by a positive because we'd end up getting negative 8y, which is what we want. So 20x plus a negative 4x is 16x equals negative 32. And then we divide by 16. So x is negative 2. All right, so now we have our x value. We just need to solve for our y value. And you just pick one of these equations. Either one will give you the correct answer. And you plug in your x value, so you're negative 2. So I'm going to do that. We've got negative 4 times negative 2 plus 8y equals 0. All right, when I multiply my negative 4 and my negative 2, I get a positive 8. And 8y equals 0. Subtract 8 on both sides. 8y equals negative 8. And then if I divide by 8 on both sides, I get y equals negative 1. So those are my two answers. If I want it written like an ordered pair, I'd write my x value first, my y value second, and it would look like that. It just kind of depends on how it asks for it. But these two and that are the same thing. Okay, now if we solve by substitution, the difference between that, which you could solve this by elimination, but I want to show you how to solve it by substitution. And the way we do that is we want to solve for one of the variables. So I want to solve for x by moving 4y to the other side. So I want to add 4y on both sides of this equation and get a positive 4y minus 13. So x is going to be equal to positive 4y when I add it on both sides. Awesome. And then I want to take, instead of writing x in this equation down here, I want to substitute 4y minus 13. And that looks like this. 4 times 4y minus 13 plus 4y equals negative 12. So notice what happened. The x disappeared. So now all I have is y's, and it's just simple algebra to solve. I'm going to distribute, make this 16y minus, I think that's 52, but I don't want to do it wrong. So 13 times 4, yes, 52, plus 4y equals negative 12. I'm going to combine like terms on this side. 20y minus 52 equals negative 12. And then add 52. 20y equals positive 40. And then divide by 20. So y is going to be 2. Awesome. Now that you've done that, you have y. You can plug in 2 for y and then pretty easily solve for x now. So x equals 4 times 2 minus 13. X equals 8 minus 13. X equals negative 5. All right, and then the same idea as before. If it asked for it in an ordered pair, it would be our x value first, which is negative 5, and then 2. All right, thanks for listening.